Rinat Nailev, and this is my final project for Computer Science 420 programming languages. It's an interpreter for a Pascal language. I built this using the Ply library in Python, and it uses an AST, or an abstract syntax tree, to evaluate programs dynamically without any bytecode or any compilation to another language. My goal was to explore how interpreters work, from lexing and parsing all the way to runtime execution. All right, let's jump right into it. The way you run the program is you go to the terminal and you say python3 xi.py, and basically any PAS file that you provide. This is a source code. Let's look at the fib.pas. It has the same syntax as Pascal, which was the purpose of the project. Begin and end blocks. You see how variables are assigned. You see how every line ends in a semicolon. All right, let's run it. It's asking for an integer on this line right here, and let's say 8, and it gives the Fibonacci for 8 is 21. Correct. It's a little bit messy because it shows everything it's doing under the hood, especially the most important thing is the AST itself. You can see how the tree is built node by node as the program is running. Let's see. So the way everything is working is everything is declared and put into a compiler right here. So we have reserved words, we have tokens, we have literals, we have all the basically all the functions of how the input is broken down into the output and how it's passed to the AST. For example, let's look at the binary operations. So it's passed as the expression equals expression plus another expression, expression minus another expression. It ties back to the overall grammar of the language. So the rules, how things should be passed to the language. Otherwise, it's not going to work. So, and then the AST breaks down as parameters. It takes the value. The value is actually what operation is currently doing, and the children are the two expressions that are being operated. So like 2 plus 2. So 2 and 2 are the children, and value is 2. It's further, it's passed into an interpreter part, which actually is the AST. And let's go down and look at our binary operations. So it matches. So here, match node.value. It matches. So it matches the value with the corresponding case. So if the value was plus, which was passed earlier, it breaks down the left-hand side, aka the children, and the right-hand side, and it does all the operations. So minus, multiplication, division, etc. So yeah, this is overall the overall like how the language works. What the trickiest part for me was to actually understand what goes where and how things affect each other, because I saw every piece of a puzzle. I just could not understand how it all came together. What helped me was spending hours basically tweaking little things here and there and seeing how this affects the output, and also the the progress reports on Moodle by Professor Wilborn were very helpful. So in the end, my interpreter successfully supports integer and float mathematics, conditional logic, loops, arithmetics, string and numeric input and output, and full execution from source code to output. This project taught me so much about the structure of programming languages and the differences between parsing and interpreting. I do feel like I have a good understanding of like all the 500 lines that are here. And for the future application, I'm not planning to do any extra credit work, but this could be a good start for any like language parsing automation tool or any like backend interpreter. But yeah, thank you for watching, and I hope you enjoyed this walkthrough of my interpreter. Feel free to reach out if you have any questions. Thank you.